Okay, continuing with part 3 at this point. Question number 14. And we're going to write an equation for the line. So we're going to use point slope form. So y minus 5 equals 7/8 times x minus 7. And it says in point slope form. So at this point we're done. Remember that point slope form, as we discussed in a previous section, is y minus y1 equals slope times x minus x1, where x1, y1 is an ordered pair, and x and y remain in the equation. In question number 15, we're supposed to find the intersection of the two sets. There are no members that are the same, so there is no intersection. Union means I'm going to put the two sets together, but intersection means what element is in both sets. So no element is in both sets. And in number 16 also, no element is in both sets. So now we're going to compute the discriminant. So as we compute the discriminant, you need to remember the quadratic formula. And as we discussed earlier, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Well, the discriminant is simply the part under the radical. So this value is the discriminant. And the reason the discriminant is so important is because you can tell what kind of answers you're going to get, and you can also tell how many answers you're going to get. So frequently you're asked, what is the discriminant? So you need to put this in standard form or set it equal to 0. So 6x squared minus 3x plus 8 equals 0 is the form that we're going to need. And a is equal to 6, b is equal to negative 3, and c is equal to 8. So looking at the discriminant only, negative 3 squared is 9 minus 4 times 6 times 8. So 9 minus 48 times 4. What is 48 times 4? 48 times 4 is 192. So 9 minus 192 equals negative 183. So the discriminant is negative 183. And remember, when the discriminant is negative, we will have two imaginary solutions. Now we're going to solve this equation by factoring. So when we solve this equation by factoring, we're going to set it equal to 0. So 4x squared minus 35x minus 9 equals 0. And 4 times 9 is 36. So factors of 36 that give you 35, that add or subtract to give you 35 are 1 and 36. So 4x squared minus 36x plus x, this is still going to give me the 35x, minus 9 equals 0 is the way I'm going to start off this problem. So I'm going to factor this. Common factor is 4x. So 4x times x minus 9 gives me these two terms. And 1 times x minus 9 gives me these two terms. So I have a common factor of x minus 9, and what's left is 4x plus 1. So when I multiply these two back together, I will get 4x squared minus 35x minus 9. And if I move the 9 to the other side, I will get what I started with. So this is the factors for these, and I can solve these by setting them equal to 0. So 4x plus 1 equals 0. So x is equal to 9, and x is equal to negative 1/4. Okay. Next page. So we're going to solve this using the calculator. So come over to our calculator friend here, and we're going to clear this by quitting, and we're going to find E, and E is in the blue right here, so second E, and we're going to plug in negative 1.1. So remember, E is a number, and when we raise a number to a negative exponent, it's 1 over that. So we're expecting that to be a pretty small number. So you can see that it is a pretty small number. And it says to round our answer to 3 decimal places. So the answer to this is 0.333. In question number 20, we're going to use what we know about logarithms, and it's going to be b to the 2 equals 4. So what number to the second power equals 4? And of course that would be 2 to the second power equals 4. So b has to be 2. Question 21. We're going to graph this using our calculator. And so when we graph this, we're going to use the calculator. So let's come over to our calculator. We're going to clear that one out. And we're going to graph the square root, so second square root of x minus 3. And so we're going to graph that one. So there's what that one looks like. And if I was required to graph it, I might look at my table. And so the table, notice there's an error here. So the first ordered pair that I get is 3, 0. So 3, 0 is right here. And it's going to be 4, 1. And 5 goes up and 6 goes up, and pretty much it's just going to kind of slant like this. So I could get a few more points on my table, but what we're going to take a look at is the inverse now. So there is my graph for that one, and there's my solid line, and notice the next one it says to make a dashed line. So the very first thing that I'm going to do now is I'm going to find the inverse. So remember, we replace f at x with y, and then we change the x and the y. So x equals the square root of y minus 3. And now I'm going to solve for y. So I square both sides, and then I'm going to add 3 to both sides. So x squared plus 3 is now what I'm going to graph in the calculator. So go back over to your calculator. And I'm going to leave that one so I can see what my final product is going to be like. But now I'm going to graph x squared plus 3. And so the dotted graph is going to look like this. But the problem is I only have a restricted domain. Okay, so since the domain for this one is going to be, and I know this was wrong on your answer key. We talked about it in third period, but I think we may have missed talking about it in fourth and seventh. But this one has a domain, which is backwards on the answer key, of 3 to infinity. And it has a range of 0 to infinity. So what you need to know about the inverse is that the domain and range are going to switch places. So the domain for this one is 0 to infinity, and the range for this one is the domain for the other one. It's going to be 3 to infinity. So we really can't graph anything smaller than 0 on this graph. So when we look at our table on the calculator, we want to look at the table. We want to look at this piece, but our smallest value is going to be 0, 3. So this is the start, and it's not going to be completely like the graph. So this is the dotted portion of our graph. And if you notice, this is going to be reflected over this line, just like we talked about. This is a reflection of this one, and that's another reason that the graph didn't continue in that area. So, page 6. Just check my time here. Okay, I think we're going to stop here at page 6, and we'll call that part 3.